The history of refrigeration is a remarkable tale of human ingenuity spanning centuries, beginning long before the invention of the modern refrigerator. Early civilizations faced the challenge of preserving perishable foods and medicines in the absence of modern technology. Ancient cultures such as the Egyptians, Romans, and Chinese used natural methods like storing food in cool caves, underground pits, or cellars, and harvesting ice and snow during winter to keep food fresh longer. The Chinese, for instance, are credited with inventing a form of artificial ice storage around 1000 BCE by freezing water in large blocks and storing them in underground pits insulated with straw and other materials. Similarly, the Romans built aqueducts and designed ice houses to store snow transported from mountains for cooling wine and food. These primitive but effective methods were critical to survival and helped develop early knowledge about the importance of low temperatures in slowing decay. However, these methods were seasonal, localized, and inefficient, prompting humankind to seek artificial means to create cold. The scientific foundation of refrigeration began to form in the 18th century during the Enlightenment, when scholars and inventors sought to understand heat, thermodynamics, and the physical properties of gases. In 1748, William Cullen, a Scottish chemist, demonstrated the first artificial refrigeration effect at the University of Glasgow by using a pump to create a partial vacuum over a container of ether, which then boiled and absorbed heat from its surroundings, lowering the temperature and producing a cooling effect. Although Cullen's work was primarily theoretical and not intended for practical use, it laid the groundwork for future developments. Shortly thereafter, in 1755, Benjamin Franklin and John Hadley performed experiments showing that rapid evaporation of liquids could cause significant temperature drops, reinforcing the concept that evaporation could be used for cooling. The 19th century was a period of tremendous experimentation and invention in refrigeration. One of the earliest pioneers was Oliver Evans, an American engineer who, in 1805, conceptualized the vapor compression refrigeration cycle, describing a closed-cycle system where a refrigerant would be compressed, cooled, expanded, and evaporated to produce cooling. Although he did not build a working model, his theoretical design influenced later inventors. Building on Evans's idea, Jacob Perkins, often called the father of the refrigerator, constructed the first practical vapor compression refrigeration machine in 1834. Perkins' system used ether as a refrigerant and operated on the principle of circulating a fluid through compression and expansion cycles to produce cold. His patent represented a critical milestone, but the technology remained limited due to the flammability of the refrigerants and the difficulty of scaling the machinery. In the mid-1800s, James Harrison, an Australian printer-turned-engineer, made significant advances by building the first commercial vapor compression refrigeration system in 1856. Harrison used ether and later ammonia as refrigerants to cool and produce ice on an industrial scale. His refrigeration systems were adopted by breweries and meatpacking plants, transforming industries reliant on fresh food storage. Meanwhile, John Gorey, an American physician, designed an ice-making machine in the 1840s aimed at cooling hospital rooms to treat patients suffering from yellow fever. Gorey's invention marked an early attempt to use artificial refrigeration for health purposes, but he struggled to commercialize his technology. The period also saw the development of absorption refrigeration, where heat rather than mechanical energy drove the cooling process, with inventors such as Ferdinand Carré and Albert T. Marshall contributing to the advancement of this technology in the late 19th century. Despite these early successes, refrigeration technology faced significant safety challenges. The refrigerants used ammonia, methyl chloride, sulfur dioxide, were toxic, flammable, or both, leading to accidents and limiting widespread adoption, especially in households. This period also saw the use of iceboxes in homes, insulated cabinets cooled by blocks of ice delivered regularly, which, while an improvement over no refrigeration were labor-intensive and unreliable. The quest for safer refrigerants and more compact, reliable systems intensified into the 20th century. The 20th century marked the era of breakthroughs that made refrigeration a household staple. A pivotal development occurred in the 1920s when Thomas Midgley Jr., working with chemists at DuPont, discovered chlorofluorocarbons, CFCs, commercially known as Freon, as a non-toxic, non-flammable refrigerant. Freon revolutionized refrigeration by drastically improving safety and efficiency, enabling the mass production of electric refrigerators for home use. The introduction of the first electric refrigerator for domestic use, the monitor-top model, by General Electric in 1927, heralded a new era of convenience and food preservation. This innovation allowed households to store perishable foods for extended periods, dramatically changing eating habits, grocery shopping patterns, and food distribution systems. During the Great Depression and World War II, refrigerator production slowed, but after the war, demand soared as economies recovered and consumerism grew. New features such as automatic defrosting, frost-free technology, adjustable temperature controls, and more efficient compressors were introduced throughout the mid-20th century. Refrigerators became more compact and affordable, spreading globally and becoming essential kitchen appliances. Industrial refrigeration expanded alongside home refrigeration, facilitating the growth of cold storage warehouses, refrigerated transport, and supermarkets, which transformed the food supply chain from local to global. However, environmental concerns emerged in the 1970s and 1980s when scientific research revealed that CFC refrigerants were depleting the ozone layer, leading to increased ultraviolet radiation reaching the Earth's surface and causing health and ecological damage. This discovery led to international action through the 1987 Montreal Protocol, which mandated the phase-out of ozone-depleting substances, including CFCs. In response, the refrigeration industry developed alternative refrigerants such as hydrochlorofluorobonds, HCFCs, hydrofluorocarbons, HFCs, and more recently hydrofluoroolefins, HFOs, which are less harmful to the ozone layer but still contribute to greenhouse gas emissions. In the 21st century, the focus shifted toward energy efficiency, environmental sustainability, and technological innovation. Modern refrigerators are designed with advanced insulation materials, inverter compressors, and smart sensors to reduce energy consumption. Digital technologies enable features such as touchscreens, internet connectivity, inventory management, and even AI-powered temperature control, enhancing user convenience and food safety. The development of natural refrigerants like ammonia, carbon dioxide, and hydrocarbons has gained traction as eco-friendly alternatives. Refrigeration technology has also expanded beyond food preservation into sectors such as pharmaceuticals, where cold chain logistics are critical for vaccines and medicines. Globally, the refrigerator's impact on public health and nutrition is profound. By preventing food spoilage and reducing foodborne illnesses, refrigeration has enabled safer diets and extended food availability. It supports modern agricultural practices by allowing the storage and transportation of fresh produce across vast distances, fostering global food trade. Furthermore, refrigeration plays a critical role in blood banks, medical labs, and scientific research, highlighting its importance beyond the kitchen. From its humble beginnings as frozen ice stored in pits and caves, to the complex intelligent appliances found in modern homes, the refrigerator as history is a testament to human creativity and the drive to harness scientific principles for practical benefit. Each step of the way, inventors, engineers, and scientists overcame challenges related to safety, efficiency, and environmental impact. Today, refrigeration remains an evolving technology, vital to sustaining modern life and facing new challenges such as climate change and energy conservation. The journey of the refrigerator, underscores how a single invention can transform society, enhance quality of life, and create ripple effects across industries, economies, and cultures worldwide.